So will these slides be available online? Unfortunately, well, they will be available if you leave your email in the chat or the Q&A section. We'll collect them and we will send you the slides in 1 to 2 working days. So you'll receive them in the email. Will the webinar be available on YouTube? Currently, we do not record them, unfortunately. So no, at least for now. Maybe we'll create a separate video sometime soon now that 5.0 is out, so you can just kind of go through it at your own pace. But no, this is not being recorded. So if everyone is ready, let's just slowly begin. If you have any questions, use the Q&A section. Just ask me any questions and we'll answer them either as we go or at the end of the webinar. If the audio is not clear, too loud, too quiet, then go ahead and tell me. I'll try to adjust. This is a 5.0 webinar, yes. So though there isn't much difference in this topic when it comes to 4.0 and 5.0, essentially just some UI elements have been changed around. I do have maybe some additional things to say since the topic at hand has changed over time. So my name's Arturs. I'm a support engineer, consultant, and a trainer at Zabbix. And today we will be covering the monitoring of your containers via Kubernetes and Zabbix, of course. We'll be talking about how to get that information out of Kubernetes and maybe why Kubernetes is the solution that we recommend using together with Zabbix. And I'll cover, like I said, some additional things that we do not cover in these slides over here. I'll just verbally kind of discuss some core points that have maybe changed over time. Let me quickly just open a Q&A section. I'll write some emails there. Slides will be shared via emails. Yes, I can see you already leaving them. So don't worry, you'll get them. I'll collect the emails after the session. So first off, let's just cover a couple of things related to Zabbix in general, what Zabbix is and how it does things, because those things will kind of directly influence how we can monitor our Kubernetes instance. So remember, Zabbix is a universal corporate level solution for real-time monitoring of metrics and analyzing them against problem thresholds and notifying you. It's also open source, which is another quite important thing when it comes to monitoring of Docker and how some of the existing monitoring approaches have been implemented. It's universal because it has a lot of monitoring approaches. And the thing is that we will be using a lot of these approaches when monitoring our containers. It won't be a single approach. It'll be a mix of different approaches. The presentation is showing the preparation slide, is it? All right, let's see. Shouldn't be, but I can do some. Let me reshare them. All right, you should be seeing my screen full on. Is the presentation fine now? Are you seeing the correct slide right now? Good, good. Didn't miss much. So we can collect data on Zabbix, for example, by using the agent, but there are a lot of agentless approaches. We can use, for example, external scripts. We can use Zabbix sender to send data. We can use HTTP agent to query some external API, and I'm covering these specific methods because maybe these specific methods can be used to monitor your Kubernetes instance. So let's move on. Once we have collected that data, we can create a lot of very custom triggers based on the collected data and the expressions that we provide for you, functions that we provide for you, but also we can use and, or, and maybe trigger dependencies to make the alerting make more sense. And once again, this is something that you will be using if you plan on monitoring your whole Docker infrastructure, not just containers themselves, but also the hardware on which they run, the cluster hardware, which is quite important. That's another layer that you cannot forget about. So once an alert is detected, of course, you get notified one way or another, or maybe you wish to execute some script to remediate the issue. Could be quite useful with containers, of course, if you don't get this into some sort of a restart loop or something like that because something is missing. And once that data has been collected and analyzed, of course, you can visualize it on our widgets or in the latest data via ad hoc graphs or see some reports that Zabbix provides on actions, for example, who was notified when, what was executed when, and so on. So here comes the beginning of the fun part. So installing Zabbix. Of course, you can install it the easy way by packages. It's a simple yum install or apt get or whatever. It's really, really easy. We now have updated our download page, COM 5.0. The instructions of how to install it are pretty much provided on the download page. No need to navigate the documentation or anything like that. It's really neat, really kind of all in one and simple. If you wish, you can also compile it from source, which is something that some of our community members have been done to monitor Docker, creating their own custom agents, just simply to monitor containers. Or you can set up an appliance, all in one solution, an image for different hypervisors that you can deploy. Last but not least, of course, you can always also use Docker. On our Git page, you should find a lot of compose files that you can tweak and tune and modify and deploy everything via Docker. And that's something that we've been pushing quite a bit. We now have our own OpenShift operator that we support that can deploy all of that infrastructure via containers on OpenShift. I've messed around with it a little bit. It's really quick. It's really nice, really easy to redeploy it or scale it up. So I definitely recommend taking a look at it. Or of course, you can just use Docker with containers from Docker Hub. Environmental variables are all documented there, and we have tons and tons of versions for those containers that you can just set up and play around with. It's quite also simple, nothing too complex. You're familiar with containers and Docker specifically. So here are some documentation links that you can use if you choose to download these slides and then later on go through them step by step. Over here is our Docker Hub page, and over here is our GitHub page for those compose files that I mentioned before. So some useful knowledge over here. Now let's talk about, as we move on to Docker, let's talk about some general concepts. So Docker, of course, is not the same as a virtual machine. We can see a couple of layers removed over here. First off, hypervisor is replaced with a Docker layer, which is a lot more lightweight. And there is no guest OS. We use all of the libraries that are provided by our host system. Essentially, it's an isolated environment of our host system. We are not virtualizing anything as it is with virtualized environments. So this is nice because it has some performance benefits, and it's also easy to scale up if you deploy it as infrastructure as a code, which is quite common nowadays. Really, really nice. The compose files that I mentioned, you can have a whole Zabbix instance running in a minute if you have the compose file prepared. You can have multiple instances running in minutes. So it's real simple. You can scale up, scale down quite seamlessly, quite quickly. You can kind of do the same on virtual machine, but not really that simple. I'd say it's a bit more complex, and there's that added overhead of guest OS. Someone's asking, do you need a Linux machine to run a Linux Docker? Yes, you do. Yeah. Speaking of this specific case, yes, you do need a Linux machine. Though there are some workarounds. You can run Linux virtualized environments on Windows nowadays also, and then run Docker from there, for example. So there's you can kind of work around that. I think Windows also has their own containers that you can use, some sort of a version of containers. So that's still possible. Someone's asking me to slow down. All right, I will. Might take a bit longer, but I will. No worries. Just tell me if you need for me to slow down a bit. So we've discussed what a container is and how it can be used. Now let's discuss one of the key resource management points when it comes to containers. We're talking C groups. And this is something that you can actually monitor. So to ensure that container doesn't hog all of the resources on your machine, we can define C groups for them, or control groups. These are essentially resource restrictions or assignments per container. And this is one way to monitor how much resources is a container currently taking up? How is it doing performance-wise? And there is a community solution that I wanted to cover today, which is not mentioned in the slides. I think it's called Zabbix. And it's actually a custom Zabbix agent, and I think a server also, completely recompiled from scratch, that support getting data from these C groups, thus monitoring the performance of containers. So someone actually took our source code, one of the community members cracked it open and added some native non-native functionality to it and recompiled it and made those binaries available to you for use. So that's really nice. Definitely take a look at it. It's a lot more simple than the other approaches that we will be covering today. Those will be a bit more complex. We'll be working with command line tools and API. Zabbix is a native community solution that I've been keeping an eye out for quite a long. It has an insane amount of downloads. It's really popular, and it seems like the creator is going to support it for a while. It's been updated constantly. So definitely take a look at it. If you Google Zabbix Docker, it'll be one of the first hits that you get. And it's based on these here C groups, monitoring of resource assignments to containers and how they are used. Now let's talk about the layers of monitoring when it comes to our Docker infrastructure. So Zabbix agent is a process that we can deploy on our monitoring targets, for example, on our cluster servers. The exact name is Zabbix. I think it should be something like this. I can quickly take a look at it in the Google. Yeah, I can even send you the GitHub page or the Docker Hub page. This here is the one that I was talking about. So there you go. I've shared it in the chat. You can take a look at it. And there you can see all of the instructions, and I'm reading examples of how that works. Moving on to the slides. So I sent it to all panelists. Okay, all panelists and attendees. There we go. Now I've sent it. Sorry, first webinar on Zoom. So you're kind of our test subjects right now. So bear with me, please. So let's move on to how we can use agent. We can use agent. We can deploy it on our monitoring targets, and we can use it to monitor some OS level metrics, which is quite important if we are talking cluster servers that are actually hosting our Docker environments. So if we deploy an agent, what we can get out from our host system is OS level metrics. CPU status and usage, memory usage, hard drive or any other storage usage, network usage, and so on. And we can see what's going on our target, on our host on that level. We can also, of course, use, for example, SNMP or IPMI or some other approach to get that hardware level data, which is kind of a bit lower. Temperature from temperature sensors, fan speeds, fan temperatures, fan statuses, PSU statuses, and so on. Which is, like I said, it's the highest level of monitoring your Docker infrastructure. So over here is a list of approaches that you should probably, if you've worked with Zabbix, already know by now. So we can use both polling and trapping. And of course, if your server cluster has an interface that can send, for example, SNMP traps, we can receive those. But we can also use Zabbix Trapper together with Zabbix Sender to receive some data from it via wrapper scripts or just natively with cron jobs or things like that. So now let's go deeper. Let's go, we've covered hardware. Now let's move to monitoring containers themselves. So we have the age-old question, Docker Swarm versus Kubernetes. Why are we covering Kubernetes and not Docker Swarm? Well, first off, Kubernetes at this point, I think, has grown quite a bit in popularity. It was more popular than Docker Swarm when we kind of started creating this webinar, and I think it has only grown over the months or maybe even years at this point. And also Docker Swarm has community and enterprise editions, so free editions and paid ones. And a lot of monitoring features and even documentation is limited behind that paywall. Well, sort of paywall. Let's not call it a paywall. Let's just call it a different version behind that enterprise version. So you don't have access to it natively if you're a free user. While Kubernetes is all completely free, has a great community, tons of developers, tons of DevOps guys, constantly, fixing issues, troubleshooting things. It also has very large amount of documentation and use cases out there. I've personally, most of the time during my trainings, during, creating webinar materials or just working on new solutions, Kubernetes is what I've encountered. I've encountered Docker Swarm extremely rarely. Kubernetes has a more robust and documented API and command line tools, which is what we are going to be using. Another thing is Docker Exporter for Prometheus. So as you know, starting since version 4.2, Zabbix supported natively gathering data from Prometheus agents. This is another thing that we can use to monitor our Docker instance and containers. When we were developing this webinar, there was a Docker exporter, so a custom Prometheus exporter that you could use in conjunction with your Docker instance, integrated together with Docker, and then Zabbix could pull data from that Prometheus exporter called Docker Explorer. So it's still there. It's still available. Definitely take a look at it. I haven't done that. I haven't checked the usability of it, how developed it is in a while. So I cannot comment on that, but it's still alive. So definitely take a look at how much data it exposes and how much it can provide for you. Maybe that is the go-to solution for you. So Zabbix for some, this here, Docker Explorer together with Zabbix Prometheus preprocessing for others. And we'll talk about some more methods that maybe fit some other people that want to see things in more detail or have their own custom solution that will monitor their containers. So over here, we can see that we can use the preprocessing to use any kind of Prometheus exporter, Docker Explorer, PostgreSQL exporter, and so on. We use HTTP check. So remember those HTTP agents that I mentioned. They're called HTTP agents, but they're actually agentless. So we create a new item of type HTTP agent. And we can then actually get the data from our Prometheus endpoint and preprocess it via Prometheus preprocessing and store it on Zabbix server in history. We won't be covering much of the orchestration features since I'd say Kubernetes is still quite robust when it comes to that. Don't have a kind of not necessary, don't have a list of those things over here since we're not covering that in this slide. We're covering more of how Docker versus Kubernetes exposes their monitoring, their metrics. And Docker has a bunch of tools that are available for enterprise users for monitoring, while Kubernetes, everything is open and available via CLI, for example, or API, depends on your flavor. So as you can see, there are some custom tools over here, even a UI for Docker Enterprise Edition, but that's, like I said, that's for the Enterprise Edition. So it doesn't really fit the needs of many. So now let's move on to Kubernetes. So why Kubernetes? It's a container and also a microservice platform that can define those microservices and work with them quite elegantly. It does have some orchestration tools. When you're defining those microservices and keeping them alive, there is a way to set that up in an automated manner. If I'm not mistaken, under the hood, OpenShift is also pretty much based on Kubernetes. When you're asking about the orchestration slide, I guess you're talking about this here, right? So once we send you the slides, you can then kind of compare this. But once again, over time, these things change a bit. They have a tendency to change. So take a look at how the situation is now, I can definitely vouch for Kubernetes. I'm not sure, maybe Docker has improved some of the things, but over here we're talking once again about the free version of Docker. So the thing is with Kubernetes, it does not dictate logging, monitoring, or alerting solutions, while Swarm kind of does a little bit. It does provide some integrations, and it provides a lot of mechanisms, like I said, API and command line tools to collect and export metrics. And of course, you should have your agent, SNMP, or IPMI monitoring for your cluster services. Now let's go, not services, but servers, sorry. Now let's go a bit deeper. Let's talk about components of Kubernetes that we need to monitor. So we will have our nodes, we'll have a master node, and then we'll have the nodes on which the pods are brought up. Pods, you can think of pods as microservices that contain those containers. And essentially, we need to monitor these on the hardware level, and then we need to monitor the health of Kubernetes also. So we have our data storage for Kubernetes, which is specified as etcd over here. We have a scheduler process, which essentially schedules other internal processes. We have our API server, which we also need to monitor, a controller manager, and then on each node we have a kubelet, which is kind of a Kubernetes agent that needs to be alive for everything to function properly. And then we have a kube proxy, which is somewhat responsible for networking to your microservices. All of these need to be monitored. And then, of course, we need to monitor the health of our pods and also maybe the health of containers inside those pods. So all of these metrics need to be exposed, either via API, either via command line tools. Since we're still running Docker containers under the hood, I imagine that Zabbix, which I provided before, would still work in this case, could still get access to those C groups and monitor those. But like I said, if we are using Kubernetes, then we have all these other components to think about. So let's talk about some of the terminology that Kubernetes uses. So we have pods, which is a basic unit of deployment with Kubernetes. Contains one or many containers that share the same IP address and namespace. So kind of a microservice, something along those lines. Then we have a service, which goes kind of in front of all of that, provides an IP address in front of a set of pods, and a policy that controls access to them. Then we have replica sets, which is a component that contains how many deployments you have and what is the desired number of backup pods going on. And then we have namespaces. Namespaces are essentially used for, I guess, isolation and assignment of permissions. They're not used every time and they're not super critical. They're used in larger organizations when you have separate namespaces, maybe for separate teams working on separate projects, things like that. And then, of course, we have metadata that we want to have access to. So what to monitor? We've covered the hardware on our left. That's our infrastructure. Things like CPU utilization, network bandwidth, pod resources, things like that. Agent can most likely get most of those if you don't have any permission restrictions. Then we have Kubernetes services. We have our Kubernetes master and services. We have our data container, the etcd, and then we have the containers and pods themselves. And then internal services such as scheduler, API server, kubelets, which are our agents, kube proxies, and so on. All of these need to be monitored. So how do we do it? This is essentially the slide. This is where we talk about our plan of monitoring all of these components. Infrastructure should be quite clear. Zabbix agent, IPMI, SNMP, SSH, whatever else. But what about those other components? So we can use kube API or kubectl for internal services and Kubernetes services. What we can do with them, we can maybe obtain them via the HTTP agent in JSON or XML. or we can push that data forward to some sort of a wrapper script written in Python, Perl, Shell. Remember, Zabbix is language agnostic. It's completely up to you how you write those scripts. And then those scripts pass the data formatted in JSON, because Zabbix communication is pretty much based on JSON formatted in JSON. And we get the output of Kube API server kubectl, parse it so it's a JSON, and send the resulting data via Zabbix sender, for example, to a Zabbix wrapper discovery rule, or send it to an external item via a script without the involvement of Zabbix sender. So here we have a couple of useful links for your Kubernetes setup. If you want to read more about that API or kubectl, there you go. But essentially, if we are sending data via LLD, for example, via Zabbix sender or via a Perl script, a wrapper script written in Perl or Python, this is how it should look like. On our left, we have a low-level discovery macro. In this case, it's CNAME, component name or container name. And then we have the container names themselves. So application 1, pod 1, application 2, pod 1, and so on. And then we can push them into Zabbix. Or we can use HTTP checks to query the kubectl, for example. So here we have a kubectl output. Let's say we are getting the health of different component statuses. Over here we can see it. We get health of scheduler, controller manager, and data storage etcd. We can see that etcd is unhealthy and we have some error message. So we format the data. So it's formatted this way. Convert kubectl output to JSON. So we have component names, scheduler, controller manager, etcd. We create a new Zabbix wrapper item, and we will be sending this JSON to this discovery rule, sorry, not item, but a discovery rule via Zabbix sender. Then we create a new item prototype, also of type Zabbix wrapper, and we'll be sending only health data for that specific component via Zabbix wrapper to this here item prototype, and then to a specific item, of course. So this is heavily based on scripting and Zabbix sender. This is one approach. This is the syntax of Zabbix sender. We will have some examples. So we're sending the data via Zabbix sender, specifying our Zabbix server, specifying our host, which is Kubernetes master, our discovery key, component statuses, and then our discovery data in JSON. As you can see over here, it's formatted in JSON and we're passing it via Zabbix sender. A script can do that. Perl, Bash, Python, doesn't really matter. Go. But we can get, of course, a lot more than component status via kubectl. And over here is a list of things. We can get pod statuses, node statuses, service statuses, a lot more. So, and then we have the Kubernetes API. This is where we could use HTTP agent, for example. So, of course, we need to obtain the authentication token first, and then plug it into our HTTP request. So, we create an item prototype of type HTTP agent this time. Key is free form in this case, doesn't really matter, but we're populating it from the macro from our low-level discovery that we obtained via kubectl. And over here we have a URL that points towards the API of our Kubernetes cluster. And over here in the header, we will pass the token that we obtained over here in our previous step. So we pass the token here as a value. And then we use JSON Path because the retrieved value is going to be JSON. And in the item prototype preprocessing step, we will use JSON Path to obtain said value. Unfortunately, the demo for this, so I got a question, can we have a short demo based on the slides? The demo is not available for this webinar, but maybe that's a good idea. I definitely suggest to send an email to partners at zabbix.com or sales at zabbix.com to request a demo for this here webinar. And maybe we will add it in the future because, yeah, I do see a use case for having a demo because this is some complex low-level discovery. This isn't simple. We're using one item type to get the discovery data itself. Then we are using a different item type, HTTP agent in this example, to work with that data that we get from sender and query it on the API of the service. So it does get quite complex. But this is essentially a curl. We are curling this here endpoint, the URL, and then we are parsing it with JSON path. It's quite simple. It's not too complex. Another way which I've actually yet to see someone do, I know our integrations team is very keen on this, but starting from version 4.2, we also have JavaScript support. So you can obtain that data via either kubectl or kube API, and you can use JavaScript preprocessing to parse that data. So no need to use JSON path, no need to use anything else. If you're good with JavaScript, you can really neatly obtain that data, format it, and store it on an item. Some examples of JavaScript, like it can be really, really complex. It can be anything, no limitations. All of our out-of-the-box integrations that we have developed starting from 4.2, and there are tons of them. If you're still using old integrations based on scripts, definitely take a look at these new ones. They're based on JavaScript and they're plug and play. So in the same way, you could use this JavaScript in preprocessing to obtain the data from your kubectl or kube API. So it all boils down to what should you use. You can use both API, Kubernetes API with HTTP checks, or you can completely rely on kubectl with Go, Perl, Bash, and Zabbix sender. Essentially use what you're more familiar with. If you feel like you're better with custom scripting, use kubectl with wrapper scripts that will parse your data and send them by a Zabbix sender. Or we can also have a mix of both, as we had in the previous example. We can use kubectl for low-level discovery, just discovering those components. And then we can use API with HTTP agent to create prototypes from items based on those discovery results that we got from kubectl and our script. We have a bunch of links. A really nice utility links at the bottom to just test this is JSON Path Validator. So once you're obtaining that data in JSON, you can use JSON Path Validator to kind of see, hey, how can I reference this specific data point, this specific pod, or this specific node that I have obtained. Or of course, if you're using JavaScript, here is a JavaScript guide. And if you're using regex at some point to extract some data via a regular expression, you can use regex 101. So once you have obtained all of that data, you can then further on visualize it. As you can see, we have added a bunch of new graphs in 4.0, and we plan on switching to this new type of graphs eventually in 5 point something maybe. I think before 6.0, we're going to replace all of the screens, all of the latest data, old school graphs with these new ones. It'll be a seamless migration. And that's pretty much it. So it boils down to using kubectl, using Kubernetes API, together with Zabbix sender, or an external script, or HTTP agent. Or like I said, use any of those tools that I mentioned before. Zabbix is one. Zabbix Docker Prometheus Explorer is another one. So definitely take a look at that Docker Explorer. I really like Prometheus and really like integrating with it. It's quite simple. You kind of try it once and you understand the syntax behind the pre-processing, so it's not too complex, and you can get a lot of that. Those exporters expose a lot. So definitely take that into account if you don't want to play some sort of a custom binary as it is with Zabbix. Prometheus Explorer may be a bit better. You don't have to replace agent with anything. You still have agent running, and then you have the Docker Explorer running side by side with it, and then Zabbix server is just getting data from it via HTTP agent. So if you're maybe still kind of not sure how to proceed with this, you can just use our consultation services, for example. You can get 10 hours of consultation for, say, Docker integration or container monitoring, and we'll gladly provide you with documentation step by step based on your environment completely. We'll analyze it, we'll document it, and we will also help you implement the best practices monitoring of containers, or maybe of your orchestration tools, or that hardware layer that we talked about in the beginning. And then, of course, once we have documented it, we will send it to you with explanations why we did what we did. There's also a live demo available over here on this here website, where you can go step by step through different Zabbix functionalities. This demo will soon be updated to add a lot more new functions and a lot more new features that we have added in 5.0. So one way or another, we will be having our Zabbix Summit event. Depends on how the situation changes all over the world. Either it's going to be live in Latvia, as it was the previous years, or maybe we'll host something online. We recently had our first meeting, and it was pretty crazy. We answered over something like 200 questions from the audience. It went to something like 3 hours. Alexei Vladishev, the owner of the company personally, was answering questions left and right. So it was really great. So we're really keen on online events, and definitely keep an eye out on the available meetups. We'd like to see you there, and we'd like to hear from you quite a lot. A lot of insight was had both for customers and for us from our customers. So now let's see if there's anything in the Q&A section. I've been keeping an eye out on the chat, and I've been trying to cover all of the questions in the chat over here, but let's see what's in the Q&A section. So how to monitor platform as a service, Docker and Kubernetes services. For example, my Docker service on GCP platform on my Zabbix server is another data center. Why can't you pass that data via Zabbix sender, for example? Can Zabbix sender, in your case, communicate with the server? If yes, then you're good to go. Just install Zabbix sender. If not, you can use some external script to gather that data. Or even better, you can store your Docker metrics in a file, SSH into that machine from the server via SSH item, and read that data via SSH. Say it's a discovery rule that's based on SSH. So there are tons of workarounds for that. What's the advantage of using Zabbix for Kubernetes monitoring over using Prometheus? Advantage, I'd say, is you're keeping things within a single application, so less bloat. On the other hand, like I said, Zabbix plays very nice with Prometheus, and if you feel like experimenting with it, that's pretty cool. You can install, like I said, your Docker exporters and then have Zabbix gather data from them and have it stored centrally. Zabbix is a lot more flexible when it comes to problem evaluations and gathering data. Docker exporter, have an exporter, you get what you get. Over here, as you can see, you can interact with a lot of Kubernetes tools on top of those using those exporters. It's really, really flexible. Let's see some more. Is it possible to monitor AWS ECS cluster with the help of Zabbix? Yes, it is, by using AWS API and that mentioned HTTP agent. But we will have AWS templates coming out soonish, so you can get that data out of the box. Is any prediction if this can be adapted to LXC container? Thanks. Haven't heard about it at all. So if you could elaborate, LXC, like I'm not even sure what that abbreviation translates to. So if you could elaborate, is it platform specific something or something else? Is there a Helm solution for Zabbix agents? Since we've been working a lot on those OpenShift integrations, there could be some coming out soon or being developed by the community. Not sure about the community ones. I'd bet that you can find something, and I wouldn't be surprised that you see something more official soonish. So let's answer some more. Would you expect it's possible to monitor Kubernetes with HTTP calls to Kubernetes API? Zabbix is itself started inside Kubernetes. Yeah, I think it should still be possible. Of course, if your container can reach that web URL, then yeah, why not? Don't see a problem with it at all. So like Proxmox container. Yeah, like someone already answered. If that LXC container will be managed by Kubernetes, it will still expose some of the data regarding the health of the containers or pods to Zabbix, either via API or kubectl. So you can still get some data from those. And once again, this method should still be using C groups. So you can still monitor usage of those C groups. You can just Google around that online and you should find something on how to do that. And then you can use maybe scripting, once again, SSH scripting or something like SSH item with some command line scripts, or just custom scripting to monitor that C group usage. So if you wish to obtain the presentation, like I mentioned before, just leave your email. I'll be here for a little bit, just seeing what's up. So if you've missed this, leave your email and you'll get the slides. So no more questions from what I can see. Thank you a lot, guys. 5.0 is out. Definitely give it a shot. There have been tons of great improvements, and trust me, we've filled out some missing pieces in existing functionality. We've added new functionality. Zabbix is more out of the box when it comes to different features than it ever was. We have changed the UI around, a lot of usability and flexibility improvements. So definitely take a look at it. And since 5.0 is out, expect some new webinars and videos out very, very soon. There already are some new ones, and there are going to be even more as we kind of discover more and more use cases for that new functionality. So thank you, guys. Have a great day. You will receive these slides in 2 or so working days, and it's been my pleasure. So enjoy monitoring your Kubernetes instance. Bye, guys.